Today we are studied the timer of the PIC microcontroller. The timer is used to measure the time or generate an accurate time delay. It is important application in the embedded system. It is maintains the timing of the operation in synchronous with the system clock or external clock. The timer is used to count cycle and perform a particular action at a specified moment or optionally start and the interrupt cycle. The digital cycle counted by the timer can be supplied internally through the peripheral clock or externally through a crystal. In this article, we will see the details of the PIC of 16F877A timer. The first one timer is block diagram. PIC 16F877 timer block diagram. The timer is nothing but the simple binary count that can be configured to count clock pulse, external or internal. Once it reaches the maximum value, it will roll back to the 0, setting up an overflow flag and generate the interrupt if enabled. Prescaler is the block of the present inside the block module, and it is used to drive the clock frequency by a constant. It allows the timer to be clocked at the rate as user desired. The first one is the PIC 16F877A timer module. The figure shows about the timer 0. The PIC 16F877A is basically has the three timer modules. These timer module terminals are also multiplexed with the other function for handling alternate function. These three timer modules as named as timer 0, timer 1 and timer 2. It is additional to the watchdog timer. These modules helps to the performs various timer counter or PWM generation. Now we have to learn deeper about these four timers modules. Timer 0. The figure shows about the timer 0. Timer 0 main feature is 8-bit timer or counter with prescaler. Readable and writable timer 0. Internal or external clock set. Built-in 8-bit software programmable prescaler. Age selector for the external clock. Interrupt on overflow from 0xFF to the 0x00. Timer 0 has a register called TMR0 register, which is 8-bit of the size. The below table shows about the associated PIC 16F877 timer 0 module. In the timer 0 consists the option register, TMR0 register, INT-con register. Option 0 register. This register is used to configure the timer 0 prescaler. Clock source. This time TMR0. This register will hold the count value. When this register overflows, then an interrupt will be generated. INT-con. This register contains the timer 0 overflow flag and the corresponding interrupt enable flag. Then next register RBPU, not applicable for the timers, and next register INTEDG, not applicable for the timer. Then TMR0 clock source selected bit 1 transistor on T0 clock 1 pin and selected bit 0 internal instruction cycle clock. Then timer 0 source edge selected bit T0 SE selected bit 1 increment on high to low transistor on T0 clock 1 pin and selected bit 0 increment on the low to high transistor on the T0 clock pin. Prescaler assignment bit. If prescaler assignment bit is 1, prescaler assigned to the watchdog timer, and prescaler assigned bit 0, then the prescaler is assigned to the timer 0. Then the workflow timer 0. Timer 0 can be operated both as timer and counter. The timer 0 store the value of TMR0 register. All the parts to the left are the clock source circuits. T0 con register is used to the program the timer and include the bits shown in figure. The clock source can be internal or external and controlled by the T0 CS bit. In some cases, the clock coming from the oscillator could be too fast for our application. We can lower it by using frequency prescaler. The prescaler is the circuit that divides the signal frequency by 2486 about f2 256. The prescaler is activated by the bit PSA. Prescaler value is returned to the timer 0 register. Programmable of the timer 0 allows the handling longer interval events with the help of only 8-bit maximum value of the timer counter. Further, the external clock frequency can higher than the device frequency. A maximum frequency that can be used a clocking source for timer 0 is limited to the 50 MHz maximum. The clocking source frequency, either the internal or the external clocking frequency T0 CKI, is divided by 2 split of the use of the prescaling or not. The timer 0 preloaded count by the timer 0 /delay is equal to in bracket timer 0 /count into prescaler value into 4 divided by frequency oscillator. Then next one is the timer 1. Timer 1 is the 16-bit timer or counter. It consists of the 8-bit register. Timer 1 is the readable or writable, internal or external clock selector. 1 to 48 programmable prescaler. External can be synthesis or a synchronization or a synchronization. Interrupt on overflow from FFFH to the 000H. Second crystal permitted. Timer 1 register. Timer 1 has a register called a TMR1 register, which is 16-bit of the size. The timer 1 module T1 con timer 1 input clock prescaler selected bit. The size of the register 8-bit and the register is used to configure to timer 1 prescaler clock sequence. Then next TMRIH. This register holds the higher 8-bit timer's value. The TMR1H and TMR1 low are used to pair out to increment of the 00H to the FFH. Timer low TMRIL. This register holds the lower 8 bits of the timer value. TMR1H and TMR1L are used to pair increment for the plus FFFH. PIR1. This register contains timer 1 overflow flag. PIE1. This register contains timer 1 interrupt enable flag. Timer 1 clock source bits is used to the select the clock source. If the timer 1 CS becomes 0, then the internal clock is given to the input of the timer peripheral. If you programmed on the 1, it will get the clock source from the external source. That external source can be timer 1 clock eye or crystal oscillator. When it can be crystal oscillator, then the T1 oscillator is logic. If it is enabled, it will get the clock pulse from the crystal oscillator. If it is disabled, it will get the clock pulse directly from the T1 clock eye pin. Prescaler bit is used to divide the incoming clock any one of the factors 1, 2, 4, 8. T1 synchronization bit logic 1, it will not be synchronized. The external clock will not be synchronized with the internal oscillator clock. If the T1 synchronization 0, it will be synchronized and it will be the given to the AND gate. Another bit of the AND gate is TMR1 on bit. If the TMRI becomes 1, then the clock moves to the TMR1 register and it will become 0. The AND gate also becomes 0. Then next one is the timer 2. The timer 2, 8-bit register, TMR12 and the PR2. Readable and writable timer 2. A prescaler and postscaler of the timer 2. Timer 2 is connected only the internal clock 4 MHz crystal. Timer 2 interrupt on overflow. PIC 16F877 timer 2 modules register are T2 con, TMR2, PIR1, PIE1. T2 con, this register is used to the configure of the timer 2 prescaler clock source. TMR2, this will hold the count value. When this register equals PR2 register, then an interrupt will be TMR2 is reset. PIR1, this register contains the timer 2 overflow flag. PIE1, this register contains timer 2 interrupt enable flag. The timer 2 workflow is the get the clock from the frequency oscillator divided by 4 and then going to the prescaler. The prescaler divided the incoming clock frequency from some factors. It may be 1, 4, 16. Then this clock frequency is given to the timer 2 register. It will be count the incoming clock pulse. As it is the counting of the incoming clock pulse, the value present in the timer 2 register is also compared with the PR2 register. If timer 2 and PR2 register are equal, the output of the comparator will be the reset and the timer 2 register. Then this is equal output is given to the input of the postscaler. It is not generated an interrupt immediately. When the postscaler bit obtain any of the value, it will generate the some delay timer 2 interrupt flag bit set. The figure shows the timer 2 block diagram. Timer 2 is also useful in the PW generation as time base. The SSP module for the purpose of the baud rate clock may use the output of the timer 2. SSP is the synchronization serial port used for the communication other destination. The output of the timer 2 can be selected by the SSP module by the software. The input clock can be prescaled from the 1:1 to 1:16 by using T2 clock PS1 and the T2 clock PSO0 bits in the T2 con. T2 con is explained in the figure 10.18. Timer 2 has the 8-bit period register PR2. Timer 2 increment from the 00 until it matches PR2 value and after the reset of the 00H during the next increment cycle. Upon the reset, PR2 initialized to the FFH. PR2 can be read or write. The match output of the TMR2 again has the postscalar 1:1 to 1:16. Any matches generate and the interrupt TMR2 IF and the PR1 if it is enabled. Post-scalar counts the number of the timers of the TMR2 register matches with the PR2 register. This helps is the counting the application where is almost 16-bit timer is required with and the interrupt on the overflow. Prescalar and post-scalar counters are cleared if timer 2 is written or timer 2 con is written or after power on reset or brown out reset or MCLR reset or watchdog reset. The register needed for the timer 2 operation INT con, PIR1, PIE1, timer 2, PR2 and the TT con register. And the additional timer is the watchdog timer. The figure shows about the watchdog timer. Watchdog timer is used to prevent processor from endless loop. The watchdog timer will reset peak microcontroller if instruction clear watchdog CLR WD is not executed periodically. The CLR WT instruction set the timeout T0 in the status register. This T0 bit is set by the during power up procedure. The watchdog timer can be reset T0 bit. This is possibly happens when the clear watchdog instruction is not executed periodically. The normal timeout period of the peak watchdog timer is around 18 milliseconds. The operation of the watchdog timer is shown about the figure. The internal RC oscillator drives the watchdog timer. The watchdog timer is enabled at the time of the device programming, and once enabled, the watchdog timer cannot be turned off. Similarly, if disabled at the time of the programming device, the watchdog timer cannot be turned by any means. There is programmable prescaling possible again with the help of the option register bits PSA, PS0, PS1, PS2. The maximum timeout period for the watchdog will be the corresponding to PS2, PS1, PS0, set 1, 1, 1 respectively. In option register with PSA1, this result timeout the period 128 into 18 millisecond is equal to 2.304 second. The operation of the watchdog timer is also affect the peak power down mode. The execution of the sleep command leads to the entering the power down mode. This also clears the watchdog timer if enabled, but keep it running condition. Upon the power on reset or execution clear watchdog timer instruction, the power down flag in status register is set. Now it is interesting to see watchdog timer timeout can also wake processor from the sleep mode. The processor then continues can clear the PD bit in status register. Thus PD and T0 bits given the information about the cause system wake up.